passport to advanced math, function interpretation and manipulation. Function interpretation and manipulation. So in this chapter, we just need to interpret functions. We just need to interpret functions, and then we just need to do some manipulations. And being well in this requires some practice to some special type of problems, understanding the motto, understanding the perspective of using functions, and then how to uh, how to model any problem, how to model any problem in terms of function, how to model any kind of problem in terms of function. Because in a couple of minutes, we're just gonna face a type of problems that is basically based on interpretation of functions and manipulating a particular problem in terms of variables, and manipulating any kind of problem in terms of variables, and then solving it, by using the mathematical tools is the main motto of why we use the functions. And excuse me, in a lot of cases, we just think about a problem, and we just take some variables, or we just get introduced with some new variables to model a particular situation or a particular mathematical problem, and then we solve it, by using the techniques or the tools of mathematics. That is the main perspective, or the main motto of this chapter, which is called function interpretation and manipulation. Do you understand why we need this chapter?
Yes.
Because we just want to model any kind of problem, any kind of mathematical problem, model any kind of problem in terms of mathematics, model any situation, model any I don't know what just happened today. I'm just making too many mistakes in terms of mathematics. Model any situation in terms of mathematics. That is what we do in function interpretation and manipulation. Now, the first thing that we are just going to talk about, that is putting variables in terms of other variables. What is the meaning of putting variables in terms of other variables? This is basically an expression. This is basically an expression in which we have some input and we have some output. This is basically an expression, and in that expression, you have some input, you have some input, and then you have some output, and you have some output. The inputs are variables, and the outputs that are also variables, and the outputs that are also variables. And this is the main goal of function. Because you are just trying to model, any situation in terms of variables. And to do that, you definitely need some inputs, and definitely you need some outputs, because you are just going to model any situation. For an example, consider this is a situation, and we have a situation, and we just want to model it mathematically. Then we just need to give some input. We're just trying to make some variables, and then we are just gonna getting out some variables. These are the inputs, of the situation, and these are the outputs of this situation. And all of them are trying to be modeled mathematically, and considering and creating an expression or a formula just like this. Because this is just a particular example. The energy E of a planet in an elliptical orbit around the sun is given by the equation E equals minus G M divided by 2n. So this is just a particular example, because here all of the inputs are variables, and they're just expressing individual quantity or individual parameter. For an example, the G, the capital G, has an interpretation like this. It is the gravitational constant. The aim, the small aim, is the mass of an orbiting planet, and the capital M, which is the meaning that it is the mass of the sun. It is the mass of the sun, and this A has a meaning of the length of the semi-major axis, and E is the energy of a planet which is elliptically orbiting around the sun. So all of them are some inputs. The inputs are A, the inputs are G, the inputs are M, and the input is also the capital M. And we're getting an output which is capital E. This is the situation. This is the situation, or this is how it looks to model any particular problem or any particular situation in terms of variables. And to model a particular situation or problem, we're just getting some outputs by putting some inputs. As simple as that. So, do you understand what I'm talking about?
Yeah. Is this basically just an equation?
Yeah, obviously, this is basically just an equation. Definitely, it's an
But is
equation.
it only for
Definitely.
this question, or is it gonna be used later?
You just need to
Just
ask the
this
question
question?
again. Can you please ask the question again in a
Yeah.
transparent
Is
way?
this equation only for this question, or is it for other questions too?
Okay, yeah, no. The thing is, we have different situations. We have different situations. It's not mandatory. It's not mandatory the how. It's not mandatory to think about how the function will look like. It's not mandatory, or it's not important how the function will look like. It's not mandatory to think about how the function will look like, rather than to think about how to model, how to how to model any situation, how to model any situation with mathematical tool, how to model any situation with mathematics or mathematical tool. You just need to understand. And this is not the equation for every single problem. This is just a very particular. This is just a very particular equation for this particular problem, particular equation, particular problem. So we have different type of equations or different equations in different situations, and that's what it's supposed to be. That is what it's supposed to be. Just consider such a just for an example, you just want to make some cake. The situation of cake, the situation of making cake is not the situation of making coffee. The situation of making coffee is not the situation making like cake. So we have different inputs. For making cakes, and we're getting an output. And in the situation of making coffee, we have different inputs and we're getting different outputs. So different situations have different equations, and it's not important to think about how the equation will look like, rather than to grow up a intuition, or rather than to grow up a skill to model any kind of situation with mathematics in terms of variables, in terms of mathematical operations, all over it. You just need to model any single situation, any single question in terms of mathematics. And the output, it means to model means modeling means building an equation. This is quite important. Building an equation. This is what I have just told you in the very beginning of this class. Modeling any situation means you just need to building an equation, because in this situation they have built an equation. Okay, this is the situation. That situation is just like some sentences, they're just telling the situation in terms of some sentences. But what we have built out from these yellow highlighted sentences, the situation that given in the yellow highlighted sentences, we have build out an equation. They have just given here in this case, but maybe in some different problem, we just need to build up such equation like this, equation like this, and then you just need to solve the problem. So maybe you just need to understand before doing the modeling, you just need to understand the problem, understand the situation, and then you just need to modeling with variables, and the output you are just gonna build an equation, and then you're just gonna solve the solve the equation with values given or assumed This is the whole scenario looks like. The exact same scenario looks like function, interpretation, and manipulation. The main thing I've just told you, all of the gist things just in just couple of minutes. All of the thing, the rest of the thing that you really need to know, that is basically you just need to know some basic algebraic manipulations and algebraic techniques. That is it. Some basic things. For example, factoring, or for an example, solving a quadratic equation or plotting a quadratic equation. You always need to have these skills, but the ultimate goal is we just try to understand a situation, we just try to model it with variables, and then we are just building an equation, and then we are solving that equation with values given or assumed. In the real life, most of the problems, or in some upper classes, wherever you're just going, whatever it is, within which field, you are just gonna solve, you are just gonna do everything in most of the cases. If you're studying engineering, in every single time, in every single day, in every single topic, your ultimate goal is understanding the situation, modeling with variables, building an equation, and solving the equation with given values or as. As simple as that. Trust me, as simple as that. Civil engineering, electrical and electronic engineering, or mechanical engineering, aerospace engineering, every time you just gonna do this. You're just gonna do this. And they're just trying to and they're just trying to help you to build this concept, how to build a situation with some variables. Okay, model with variables. Okay. So the first question was the energy E. Can you see it clearly? And if you don't see it clearly, then I'm gonna erase all the
Oh yeah, I can.
annotations. Okay, so the energy E of a planet in an elliptical orbit around the sun is given by the equation, in which G is the gravitational constant, M is the mass of the sun, M is the mass of an orbiting planet, the small m, and A is the length of the semi-major axis, because it's an ellipse. Semi-major axis. This is the major axis, this is the minor axis. The semi-major axis is maybe this, and maybe this is semi-major axis. This is A, and for LH, this is called B. This is the semi-minor axis. We have major axis, we have minor axis, we have semi-major axis, and we have semi-minor axis. So the A is the length of the semi-major axis, and of the ellipse made by the planetary orbit. What is the value of a planet's mass in terms of other values? Man, it is so simple. It's so simple. They have just given you this equation: E equals G M but twice A, and they have modeled. And this very equation in this violet color, this is nothing but this. This is nothing but this. Building an equation. They've already built an equation for you. And now they're asking you, what is the value of the planet mass? Wow. This is just like this. Solve the equation with the values given or assumed. This is it. As simple as that. And you just need to find the value of the planet's mass, which is m, small m. And they have already told you in the question that What variable is meaning what? What variable is meaning what? They've already told you what variable is meaning what. What is the interpretation of capital G? This is gravitational constant, which you have covered in the physics or the gravitation chapter, which you have covered in the physics, physics, maybe epiphysics or whatever it is. So this is capital G. They have told you the meaning of the variables. Now you just need to manipulate this equation, as simple as that. Fine, as simple as that. Baby child can also do it, I think. Do you have any issues?
No, not so far.
It's simple. It's simple. It's simple. The thing that I have told you that is basically the most important thing. This is basically these violet colored things, stuff like this. Now I'm highlighting. Understand the situation, modeling with variables, building an equation, solve the equation with given values or results. Because it is, I'm telling you from my own experiences, and that's why it is going to really work it for you. Because I'm telling it from my own experiences. It's not a bookish knowledge. Not something I've just memorized it. I've not just something I've memorized it and I'm just telling you. It's quite real. What is the value? What is the value of twice n minus 1 in the equation below? Okay, so I think, are they trying to tell something? I don't know. I'm just looking at the solution. Maybe they're just trying to tell you something. I think I should read it at this moment at least, because maybe the question is not as simple as that. Just my sixth sense, from my sixth sense. As a general rule, when the SAT asks you to find the value of an expression, there will be a straightforward way to find it by treating the expression as a whole unit. This problem is no exception. We don't need to solve for n individually. Instead, we can manipulate the equation to isolate the expression twice n negative 1. Okay, I was just thinking they're just becoming too much nerdish and telling such some special things, but no. Okay, all right. Very simple. Twice n negative 1, put in a parenthesis and divide by 3. For your convenience, I'm just giving you the parenthesis. It will also help you do it. And then twice n negative 1 divided by 3. I'm sorry for my bad handwriting. 8n negative 4 negative 11. You're just taking this negative 11 the right side of this equation. The sign changes. And then from this line, twice n minus 1 divided by 3 is equals to, you just need to solve it. 8n minus 15, and take this 3 to this side, which will become twice n negative 1. I'm sorry, you just need to, you don't need to use any parentheses in here. Twice n negative 1 is equals to 3, 8n negative 15. And now I think we are just asked twice n minus 1. This is how the things will look like, maybe. Twice n minus 1 equals 3. How? I don't understand. Twice n minus 1 divided by 3 plus 11 equals 4. Multiply both sides by 3. Twice n negative 1 divided by 3 equals 8n minus 15. Okay. Looking like this. I think they're just trying to tell you the problem is no exception. As a general rule, when SAT asks you to find the value of an expression, there will be a straightforward way to find it by treating the expression as a whole unit. The problem is no exception. We don't need to solve for n individually. Instead, we can manipulate the equation to isolate the expression twice n minus 1. OMG, they're really being some nerdish. So the thing that you need to do is here, you just need to make it look like twice n minus 1 in the right side also. Twice n minus 1. At this moment, just consider like this, 3, 8 n minus 15. So I have just came into this way. But actually the answer they're just wanting you from, that is like this way. So what is the meaning? they're just trying to do. They're just trying to make the equation in such a way that this twice n minus 1 is just an unit. Okay, you just cannot solve this problem just like an equation. You just cannot solve this problem just using the concepts of equation and then solve it for n equals what. No, you cannot do it. Do you understand what I'm talking about?
Yeah. Yeah.
It's a very sensitive thing because I have also made a mistake. Okay, I have also made a mistake. So I did a mistake. So be serious about it. So you cannot solve it for n. You just need to make twice n minus 1 as an unit. Twice n minus 1 as an unit. You just need to treat it like an unit, as a whole part. As a whole part. Okay. You cannot solve it for n equals 1. So your goal should be you just need to bring something like this in the other side. In the other side. In the other side. So how that will be? Factoring. This is what we're just doing the factoring. We're just taking twice n minus 1 common, and we're just doing some factoring. And then we're just multiplying both. We're just multiplying both sides with 3. And multiplying the both sides in the 3 becomes like this. And then subtracting twice n minus 1. Subtracting twice n minus 1 becomes like this. This is it. And they're just doing. And so the value of twice n minus 1 equals 3. So if I'm going to solve it like this way, it will not be correct. Okay, it will not be correct. And maybe I think this example has some real values, because maybe in future you're just going to solve this type of problem in as a part, just a small part of another problem. So you cannot just solve it in this way. This is wrong. Okay? So this is wrong. You cannot just solve it in this way. So this is not an equation-based problem. So maybe they will just try to make you understand that you just need to treat the twice n minus 1 as a whole number, as a whole part. As a whole part, you cannot just solve it with the concepts of like equations, but maybe it will be transparently declared. It will be transparently mentioned in the questions. Do you have any questions still now?
No, not yet.
Okay, all
But
right. So
wait, 1 second.
Sure.
Yeah. No, I just so 2n minus 1 over 3 plus 11. Did you
Okay.
how did you the 4, 2n? How did that happen?
Factoring, I told you factoring. I
Yeah,
told you.
but do you
Okay.
reverse the steps or what?
Yeah, reverse the steps. Because we need to look at like twice n minus 1. Okay, we need to look at like twice n minus 1. So to make it look like twice n minus 1,
Okay, and then
from
in the next step,
8
it
n
goes
minus
from
4. 8 n minus 4. So 8 n minus 4. So just like we can take it twice n minus 1, just reverse it. Just write the first twice n minus 1. And then what number, if I'm going to multiply with this, what number, if I'm going to multiply with this twice n minus 1, it will look like this. Simple, 4. If I'm going to multiply 4 with this twice n minus 1, it will look like this, because I'm writing the second line first. And then I'm just trying to getting back to the first line. This is reverse engineering. Do you understand?
yeah. But also
Eight,
in the next step, it says the 2n minus 1, and then under that the 3 goes to 33 and then 12. How does that happen?
because they are multiplying the both sides with 3. If you
Oh,
multiply,
oh,
just take some curly braces here.
okay.
Take some curly braces here, and then multiply 3, and then multiply 3. And if you're gonna multiply these 3 with, okay, some lines they're not showing here, but let me show you. Okay. So curly braces, you are multiplying. So you just need to multiply this 3 with this term, okay? This term, you're gonna multiply it. So, okay, I'm gonna write you the whole thing. Twice n minus 1 divided by 3 plus 11 into 3 equal to 4 twice n minus 1 curly braces 3. So the next line would be, you just need to multiply this 3. You just need to multiply this 3 with this term and with this term, right? Do you understand?
Yeah.
If you multiply this term with this term, then this 3 in the denominator and this 3 in the numerator will be cancelled, right? It will be cancelled, right?
Yeah.
And then what remains? That is on the only thing remains, that is twice n minus 1. Right?
Yeah.
Okay, all right. Twice n minus 1 multiplied by 3 plus 11 multiplied by 3. This is the most breaking part because I'm breaking. It's too much fundamental right now. 4, 3 multiplied by 4 multiplied by twice and minus 1. Do you understand, at least at this moment?
Yeah.
And then this 3 and this 3 is cancelled. So twice and minus 1 plus 33. 11 multiplied by 3 is 33 equals to 12 twice n minus 1. Do you get it?
Yeah.
Twice n minus 1 plus 33 twice n minus 1 plus 33 is equals to 12 twice n minus 1. Do you get it?
Yes.
And now you are just subtracting twice n minus 1 from the both sides of the equation. Twice n minus 1 both sides from the equation. How do you do it? How do you do it? If you're just gonna subtracting twice n minus 1 from the both sides of the equation, then it becomes 33 equals to 11 twice n minus 1. Okay, all right. I'm gonna write the whole thing, every single thing for you. You're just dividing, you're just subtracting twice n minus 1. 12 twice n minus 1 minus twice n minus 1. This twice n minus 1, this twice n minus 1, this is plus and this minus. They're cancelled. The only thing remains in the left side is 33, right? Hello.
Hello. Yeah.
Do you understand?
Yeah, I'm listening.
Okay, then 12 negative 1. What is happening? This is 11. 11 twice n minus 1, right?
Where'd you get -1?
Sorry?
Where'd you get the 1 from? 12 minus
Because I just asking this negative twice n minus 1.
No, because it was 12 and now it's 11.
Oh, because I'm just subtracting this 12 twice n. 12 multiplied by twice n minus 1, negative twice n minus 1.
Okay.
I'm just subtracting from this.
Yeah. Okay.
I'm subtracting from this red mark region. I'm subtracting from this red mark region. What I'm subtracting? I'm subtracting the black mark term. I'm subtracting the black mark term from the red mark term.
Okay.
Because you are just considering this twice n minus 1 as a whole part, right? Practice it. You are just gonna practice, you will automatically understand. Use some pen and paper. Use some pen and paper. Okay, so identifying constant problems. So if x plus 4 whole squared plus 5 equals x squared plus bx plus c, what is the sum of the constant a, b, and c? If x plus 4 whole squared equals 5 x squared plus bx plus c, what is the sum of the constants a, b, and c? What is the sum of the x is a plus b plus c? So the thing that we need to do, that is, we just need to simplify this polynomial. Just be a little bit concentrative. Just x plus 4 whole squared plus 5, right?
Yeah.
So what thing do I need to do? We just need to expand it. And to do it, x plus 4 whole squared is x squared plus 2x4 plus 4 squared plus 5. Okay. And then it is going to be x squared plus 8x plus 16 plus 5, right?
Mm.
So it is going to be x squared plus 8x plus 21, right? So
Why did you
x
get 20?
21 because this is 10, 16 plus 5 equals 21.
Okay. Okay.
X squared plus 8x plus 21. You just need to equate it.
Yeah.
You just need to equate this expression. You just need to equate this expression with some another equation. And that another equation is x squared plus bx plus c. And whenever you are just equating two similar types of equations, this process is called coefficient equating. Coefficient equating. It's a process. It's a very important process, and you will solve it whenever you are just using some partial fraction, doing things, or etc. etc. It's very necessary. It's very mandatory. Okay. Coefficient equating. It's a process. It's a process, and the output of this process is you are gonna correlate. You are gonna correlate with the variables, similar looking variables. You are going to correlate with the similar looking variables.
Yeah.
You are going to correlate with the similar looking variables, similar types of variables. This is the process of uh, process of coefficient equating. So if I'm just gonna doing this same thing, this coefficient equating, then what do I get? What do I get? I get the x squared term here and this x squared term here. So the value of this coefficient, because I'm equating x squared as ax squared, I'm equating 8x is equals to bx, and I'm equating 21 equals c. So what is the value of a? The value of a is equals to 1. Am I correct? And the
Why is
value
it?
of b of equals to 8, and the value of c is equals to c.
Oh, okay.
You have a question, you can ask me.
No, it's okay.
You are just gonna equate, okay? X squared equals
Okay.
ax squared. A equals 1. This is gonna be 1. This is gonna be 1 because this is you are just equating.
Yeah.
This x and x squared is cancelled, and then a becomes 1. And then this x and x is cancelled, and this base becomes 8. And this c is already 21 because we don't have any kind of variable associated with this c term, with this term. We don't have any variables associated with this term. Even we don't have any variables associated with this. We don't have any variable associated with this. And that's why c becomes 21. Okay?
Yeah.
This is it. Okay. Maybe they're just too much subtle here. They're really not telling you anything. Okay, so a equals 1, a equals 1, b equals 8, and c equals 21. So you just need to know the sum. You just need to take the sum. A plus b plus c. This becomes 30. Because for a, you just need to write 1, for b, you just need to write 8, and then for c, you just need to write 21. You just need to sum it, and then it becomes 30. Do you understand?
Yeah.
Okay, now example number 2. Okay, then example number 2, f of x is equals to x minus 4 multiplied by x plus 11. So what we're gonna do here? What we are gonna do here? So, in this equation above, which of these values is displayed as a constant, or constant or constants? In the equation above, which of these values is displayed as a constant or constants? In the equation above, which of these values is displayed as a constant or constants? So the question they're asking, that is, you just need to find out. You just need to find out the values. You just need to find out the values that it is constant or constants. So to solve it, what should be our procedure? Our procedure should be, we just need to simplify it. We can simplify it, and then we can just look at the options they're just giving us. The options they're just giving us. The options they're just giving us. Just like y-intercepts, x-intercepts, x-coordinate of the vertex, and y-coordinate of the vertex. At least simplify it first of all. At least simplify it first of all. So f of x is equals to x squared negative 4x plus 11x negative 44. Okay, x squared plus negative x squared negative 4x plus 11x negative 44. So simplified more, x squared x squared plus 7x negative 44. And now it becomes a quadratic equation. And now it becomes a quadratic equation. Now it becomes a quadratic equation. And a quadratic equation represents a parabola. And why I'm telling these words, why I'm telling this parabola, why I'm telling this quadratic equation, because this is how your mind should work. This is how your mind should work. This is how you should think, because the neural networks inside your head, you should always think about geometrically, you should always think about algebraically, and you should always think about in terms of different ways that are possible. Because this f of x is nothing but just a quadratic equation, and a quadratic equation always represents a parabola. A parabola, because we have already covered that chapter. We have already covered that chapter. Why this quadratic equation is called a parabola? Because if we plot this quadratic equation, then it look like a parabola. It will look like a parabola. Okay. So this is it. So this is how it gonna work. So we have y-intercepts, we have x-intercepts, we have x-coordinate of the vertex, and we have y-coordinate of the vertex. So the constant here, they're just asking us, we're interested about the constant. We're just interested about this negative 44. What is that? What is the value of this? What is the meaning? What is the meaning? So this equation, we have some limitation. The limitation is we just cannot consider it in the parabola. Okay. We just need to consider it with the some arbitrary positions. We can solve this equation. We can solve this equation. There's a quadratic equation. We can solve this quadratic equation, but solving this quadratic equation can be a little bit easier. Solving this quadratic equation can be a little bit easier in terms of uh, finding the constants. Okay, finding the constants, because in this question we are asked that in the equation above, which of these values is displayed as a constant or constants. So the question that they are asking, the question that they are asking, that is the questions that they are asking, that is, if you're just gonna solve this quadratic equation, this yellow mark quadratic equation for x, then you get what? You get the answer for the variables of x. If you solve this equation, x squared plus 7x minus 44 for x, what is the value of x? You can solve it, but that won't help you. That won't help you. That won't help you to find the answer, because we are asked the constant that are displayed in this equation, what they represent. So you don't need to solve the equation. You don't need to solve the equation. You don't need to do that. You don't need to do that. Rather than you just need to find the zeros of the equation. Zeros of the equation. You don't need to find the zeros of the equation. You don't need to find the solve of the equation. Rather than you just need to find the zeros of this equation. And what is the zeros of this equation? What is the zeros of this equation? The zeros of this equation means that at what point the at what number the value of this polynomial or this equation or whatever it is will be zero. And we are already given in the factorized form. We are already given in this factorized form that x minus 4, x plus 11. This is in factorized form, right? They're multiplied to each other, and that's why we are calling them, they are represented in the factorized form. So if you are just gonna think about it, then you just need to find the zeros of these polynomial. If you make it, or if you just break it into polynomial, you can think about the zeros of the polynomial. You can just analogously relate with the concept of the zeros of the polynomial, because if you multiply these two products, you are just gonna get a polynomial. And the zeros of that polynomial, the zeros of this polynomial would be the constant that are representing. Is that y-intercept? Is that x-intercept? Is that x-coordinate of the vertex? Or what? Is that y-coordinate of the vertex? But we are not going to do this. We are not going to solve the equation. We are also not going to make it a polynomial and then solve the zeros of the polynomial, because that are too much lengthy. Then what can we do? What is the easiest step that we can take to solve this problem as soon as possible and as less time as possible? What can we do? The thing that we can do, that is, we can find such number that will produce 0 for each of these terms multiplied with each other, the product, okay? These are product form. These are represented in the product form, multiplication form, and we just need to find such number which will make this term individually 0 and this term also individually 0. So x minus 4 is equals to 0. What is the value of x? X equals plus 4, right? And x plus 11 equals 0. We're considering it 0. Then what is the value would be for x? That is negative 11. Negative 11 and plus 4, right? So plus 4 and negative 11, that is the zeros of this function. And the 0 of the function where the x is intersecting the x-axis. So we can say that x-intercepts are displayed as constant in the function.
So it's the x-intercept? Yeah,
the x-intercepts, because we are solving for x, because we are considering it again as 0, and we are also considering it as 0. So if you are just equate it with this term with 0, if you are just going to equate this green highlighted term with 0, and if you also equate this green highlighted term with 0, then what you get? You get plus 4 and negative 11. And that is the reason we are just telling that it is x-intercepts, because x equals 4, and x equals 11 is nothing but some straight line which is parallel to y-axis. If you remember the concepts of coordinate geometry, this is x-axis, this is y-axis. So x plus 4 is just gonna be this red line, and the x equals negative 11 is just gonna be this violet line. It is the point. This is basically the x-intercepts. Okay.
Mm.
Do you get it?
Yeah.
You just need to practice it. You just need to think about these problems, because if you're not gonna spend a lot of time inside your brain, if you're not gonna spend a lot of time thinking about these problems, you are not going to solve. It's not possible for anybody. It's not for possible for anybody. If it's not just only me. And the only thing that I'm just solving these problems because because I'm older than you and I've already solved this type of problems. Previously, I attended the classes because I have just covered these things when I was in at your age. So the concepts that I have built in your classes while at your age, that is helping. That is helping me. And the problems that now I am dealing with at my university classes, that also requires to remember some of this portion. And that is why I can solve this problem. But as you are a beginner and you're not supposed to know everything, you need to practice, you need to understand, you need to think about. And after that, you are just gonna solve the problems. You're just gonna hold that ability to think about the problems. Now, interpreting functions, okay? I thought the class would be too much easier for all of us, but the situation is not like this. I thought I'm just gonna give some overview, but um, I think we need time. Okay, so example number one is saying that a company's profit P for selling end products is modeled by the following function. P equals negative 10n squared plus 3n negative 1000. A company's profit P for selling end products is modeled by the following function. So I have already told you that, do you remember this point, the situation that we told you, this is modeling, modeling with variables, building an equation, and solve the equation with given values or assume, right? Do you remember?
I think probably. What was it about?
Uh, the main motto. What is the main motto basically for any kind of function interpretation and manipulation chapter? What is the main motto? We just try to understand the situation. We just try to understand the situation, and then we just try to model with variables, and then we are just gonna build an equation. Okay,
Mhm.
this is our main motto of this chapter, because whatever you are just gonna do here, whatever you are just gonna do here in this chapter, you always need to look the exact same thing here again and again. Okay, the exact same thing again and again here.
Also, after this, can you send the PDF with the notes for this?
Obviously, I can send it for you. Okay, so the so here they have just modeled. They have just modeled. They have just modeled. They have just modeled a situation. Okay, they have just modeled a situation here. They have just modeled a situation here. Okay, so they have
Mhm.
just modeled a situation here, and then after the modeling, we get an equation. Okay, and we know that modeling is made by producing an equation, because modeling is nothing but producing an equation. Because whenever we're just trying to model, we our main goal to model is we just want to write an equation in terms of variables. Writing equations in terms of variables. Am I correct?
Yeah.
So this is the equation that they have given you, because they have modeled a situation, a particular situation. Maybe they have just analyzed. They have analyzed for a particular company, and they have just give up some um, mathematical statistical models, and finally they have come out with this equation. So finally they have just come out with this equation, because they have, before getting this equation, they have done a lot of steps, but we're not interested to look at those steps, or we're not really interested to think about how they have finally found out this equation. We're not going to think about that. That is not goal right now at this problem, at this very particular problem, rather than we have just given just an equation. And then and then they have just telling you how many products should the company sell to achieve its maximum profit. A company's profit P for selling end products is modeled by the following function. This is the equation. This is the equation for the company's profit P. This is the equation, okay? For selling n products is modeled by the function. This function is given. How many products should the company sell to achieve its maximum profit? So, so how can you solve it? How can you solve it? The thing is that they're just asking you that what is the maximum profit should be? How many products they should sell to achieve the maximum profit? How many products? How many products they should really sell? The company should sell to achieve its maximum profit. Should they sell 10 products to achieve the maximum profit? Should they sell 12 products to achieve the maximum profit? Should they sell 15 products, or should they sell 18 products? This is the options. And you just need to, if you just look at this equation, you can see that this P equals negative 10 n squared. We have a negative sign. That's not a good symbol. That's not a good, basically a forecast, okay? This is not a good sign. And we have, at the end, we have negative 100. That is also negative. So whatever you have just putting this value for n, for an example, you can also put n equals 1000, whatever it is, or n equals 9999999. But remember that we have also this negative sign. So whatever you are just gonna put the number as n, the ultimate answer of this term is gonna be negative. It's gonna be negative. Am I correct? And this is also gonna be negative. This is also gonna be a negative. It is also gonna be a negative. So the thing that you really need to do, that is, you just need to think about how can you achieve the maximum profit. Should you do the option test? You can do the option test, but that is basically too much time consuming. You can do the option test because we are just given some particular options. We have given 10, we have given 12, we have given 15, we are given 18. So you can do the option test, and then you can just find a value for
Wait,
p.
I have
For
a
an example,
question. I
yeah,
have a
sure,
question.
sure,
So
sure.
if you're doing the option test, would you like plug the options in the end?
Can you please ask the question again?
Okay, so if you're talking about the option test, the
Okay.
all four of the options, would you plug them into the end to see if it's right? Or what?
If you're gonna do the option test, you're just gonna think about what for n equals 10, what is the value of p equals what? For n equals 10, what is p? For n equals 12, p equals what? For n equals 15, p equals what? For n equals 18, p equals what? So you just need to find out the p, the corresponding p for the corresponding n, the corresponding p for the corresponding n, and then you just need to compare the p. Which p is the greatest? Which p is the
Oh, okay.
greatest? The greatest p. The greatest p, the greatest p, the greatest p, the n that is causing the greatest p. The n, the value of n that is that is giving you the greatest p value, the greatest p, the value of n, the corresponding, this is basically corresponding n value, corresponding n value of p, corresponding n value of p. So if you are just going to do this with the option test, you can do like this. So the thing that is better for you, that is, you just need to practice it manually. I should say that analytical procedure, analytical procedure. You just need to think about the analytical procedure, and then you just need to think about the analytical procedure, and then you just need to think about the option test procedure. That the less time taking procedure should be done by you, or you should use that. Okay. you should use the less time-taking procedure, because this is the analytical procedure. Because I haven't still told you about the analytical procedure, but you just need to give me some time, because basically I'm gonna talk about the analytical procedure, but but before doing that, I'm just telling you what actually the problem is, because we have also many problems like this. We have also problems like this. I'm gonna talk about some pretty basic problems about that. So the option test procedure I've told you, because you can solve this math problem. There are two different procedures. Okay, there are two different procedures. Let's consider two different procedures. So I've told you the option test procedure. What is the option test procedure? You just need to find the value of p for n equals 10, n equals 12, for n equals 15, n equals 18. What is the value of p? And then you just need to compare. You just need to compare the value. You just need to compare the value of p, and then the biggest p, the biggest p, the biggest p which is caused by the value of n, the biggest p which is caused by the value of n is our answer. Now just look at the another procedure, how we can solve it analytically. To solve this problem analytically, you really need to use the concept of calculus. To solve this problem, analytically, you just need to use the concept of calculus. And for any kind of equation like this, from basically calculus, you can say that for any basic kind of equation like this, y equals ax squared plus bx plus c, the biggest value, the maxima and the minima, the maxima is equals to x equals to negative b by 2a. X equals negative b by 2a. This is the biggest concept, the most important concept related to this mathematics, because for any kind of given equation like this, x squared plus bx plus c, the maxima is located at x equals negative b by 2a. And they're using the concept of calculus, but they are not telling you that they are using the calculus. They're just taking some concept. They're just talking about parabola. They're just talking about vertex, whatever it is. These equation look like this. This equation look like y equals ax squared plus bx plus c, isn't it? This equation, right? Isn't it? Are you agreeing with me?
Yeah. It's the same.
This equation looks like this. The form of this equation, this p equation, p and n, the equation that is consisted of this p and n, I am talking about this equation. The formation is also like the similar. And this equation, y equals x squared plus bx plus c, for this type of form of equation, the maximum means that for what n value, for what x values we are going to get the biggest y value. And to answer this question, the question is for what x values we are going to get the biggest y value. To answer this question, the answer is x equals negative b by 2. X equals negative b by 2a. Y equals x squared plus bx plus c is an equation. And for what x values, we are going to get the biggest y value. For what x values, we are going to get the biggest y value. What is the values of x? the values of x is equals to minus b by 2a. X equals negative b by 2a.
So that would
This
be
is
negative 300 over 10a or 210.
exactly negative 300 divided by 2 negative 10.
Okay.
That is it. This is finding the values of n equals to finding the values of x for y equals x squared plus bx plus y equals x y equals x y equals x squared plus bx plus c, right?
Mm-hmm.
Because you are finding the n. This p is nothing but just the y, and this n is nothing but just the x. So you're just asking, they're just asking what is the values of x, what is the values of n. N is representing indirectly the values of x, right? Because they both are the form of quadratic equation.
Yeah.
Because they both are the formation of polynomial, second degree polynomial. A quadratic equation is a second degree polynomial. So this is basically a second degree polynomial. A polynomial with its maximum exponent when it is 2, it is called second degree polynomial. So we have the highest exponent, that is 2, and that is why we are calling it second degree polynomial. Second degree polynomial. We are calling it second degree polynomial, and a quadratic equation is nothing but just a second degree polynomial. Nothing but a second degree polynomial. And this type of second degree polynomial, the biggest y value happens, the biggest y value occurs when x equals to negative b by 2 happens. The biggest y value happens when x is equals to negative b by twice a happens. This is the concept of pure calculus, and this is not just some uh, child game calculus. This is not some child game calculus. This is some applications of calculus, and this is why we are using calculus. Why? Because this is one of the most fundamental application of calculus, and this is discussed in a chapter called Applications of Calculus, Maxima and Minima. We have also so many different concepts. I'm not going to talk about that, but they're just bringing some concept like parabola, etc., etc. Things will become really too much tough for that, at least for you right now at this moment. I could have talked about that, why this they're just talking about parabola and why they're just giving you this type of things. But if you really, at least at this moment, if you really can just remember this point, then you can solve this problem. But the topics that they are talking about here, this yellow marked region, I'm talking about this section, they're just talking about, they're basically telling you, they are just basically telling you how this equation produces the biggest y value, how this equation produces the biggest y value for x equals negative b by 2a. They are just trying to relate with the calculus and the geometry. And after doing that, they're just giving you, by collaborating the concept of analytical geometry and graphing or plotting, and giving you an explanation. But if you at least understand, try to understand at your home, why the application of calculus in finding maxima and minima, how do we do it, how and why x is becoming negative b by twice a, why and how, what is the derivation, what is happening and how it is happening. If you understand, if you try at your home, opening some calculus text, you will understand what basically they are talking about, because they are just they are just talking about everything about the basics of that calculus. They are just pulling that calculus concepts and they are just trying and applying it on just some parabola type of shape, and they are now just telling something. But I suggest you to at least excuse me, I suggest you to at least try to understand, or at least search on Google maxima and minima, on Google maxima and minima in calculus, in differential calculus, maxima and minima in differential calculus. Then you will understand why we are calling x equals negative b by 2a is such a value, what is producing the biggest y value for the equation look like ax square, y equals x square plus bx plus c. And after doing that, I'm suggesting you to read this. After doing that, I'm suggesting you to read this, but I'm not going to talk about much more about that. Then the explanation will be too much lengthy and hectic. Whatever it is, I'm suggesting you to check it out, do some internet, do some internet things. Okay, so internet, internet or YouTube, whatever it is, find it. Okay, so the next problem is, do you have any questions?
No,
Do you have any questions?
no.
Are you sure?
Yeah.
How sure?
I know you talked about the negative b over 2a before, so it's not that difficult.
uh it's just difficult, not anything else.
No, it's not very difficult.
No, it's not very difficult. Exactly, it's not very difficult. It's helpful. Okay,
Yeah.
it's really helpful. Whenever you're just bringing the at least just memorizing some formula just for SAT test. Maybe you just I always tell you that you don't need to be a mathematician for to do well in SAT. Rather than you just need to know how to calculate the problem easily. And option test is not good at this format. This is an excellent problem. This is an excellent problem. This is an amazing problem. Amazing problem. Amazing problem. So I'm not gonna suggest you to do any option test for this problem. Just try to memorize this equation, and I'm suggesting you to also look about the maxima and minima. Okay, must read maxima and minima, because maybe they're just asking you maximum just for this particular problem, but in some other cases you are gonna also need to find the minima. You are also gonna need to find the minima. Okay, so definitely checking out the formula or the concepts of minima will really help you in the and benefit you in exam hall. Maybe who knows? Maybe they're not just asking some maximum, they're just asking you some minimum. I think we're just gonna solve at least one single problem in our practice problem or real problem about talking about the minima, because the minima is really important. And I don't think at least this lecture note is just going to cover only the single concept of maxima. I think there are going to also topic like minima, whatever it is. Now at least try to focus on the example number 2. So they're just telling that in this equation nx squared plus m equals 5x squared plus 12. Okay, there are infinitely many solutions for x. Yes, there are infinitely many solutions for x. What is the product of the constants m and n in the equation? In the equation nx squared plus m equals 5x squared plus 4. There are infinitely many solutions for x. What is the product of the constants m and n? What is the product of the constants m and n? Do you understand at least what they are telling about? You just need to give me just give me some things. You just can just tell me, what do you understand, what are basically they're
That
talking about.
that there's like every solution would work, and they're telling you to find n and n.
Yeah, yes, they're telling you to find m and n, but okay, so can you please at least tell me what can you do?
Build an equation.
Build an equation and build an equation. Hmm. uh, Build an equation. Yeah, maybe building an equation might help, but rather than we should take some other approaches, maybe. So let's look at the solution, what they're approaching. Okay,
Mhm.
so think think through solution. I'm talking about the solution. Think through what you know about equations for there to be infinitely many solutions. The equation can be formatted so that what is on the left side and the right side are identical. For an example, x plus 5 equals x plus 5. What would have, for example, x plus 5 equals x plus 5 would have infinitely many solutions, since any number can be plugged in for x to make the equation true. Yeah. So let's apply the same idea to this problem. For this equation to have infinitely many solutions, the two sides should be equal. So I think they're just talking about coefficient equating. Have we talked about coefficient equating?
I don't think so.
Yeah, coefficient equating process. Okay. Let's guess that I think they're just gonna solve this problem also by using the coefficient equating concept. So 5x squared plus 4 equals 5x squared plus 4. Therefore, n equals 5 and m equals 4. n equals 5, n equals 5, and m equals 4. n equals 5, n equals 5, m equals 4. That's it. The product comes from multiplying the two numbers together. Thus, the product of 5 and 4 is 5 cross 40, that is equals 20. Choice D. This is coefficient equating. Okay. This is coefficient equating. What is coefficient equating? Basically, they're using the concept called coefficient. I'm sorry for my bad handwriting. I'm extremely sorry. Please pardon me. Coefficient equating concept. Okay. So the basic concept of coefficient equating is just give you an example. For an example, ax squared plus bx plus c is equals to f x squared g x plus h. Just consider this equation. These two different equations. This is one equation, and this is another equation. And this x squared, we have x squared, and we have also x squared. We have x, and we have also x, and we have c, and we have also h here. We have constants. So the coefficient equating tells you that if these two are similar, if those two are identical or equal, then from this process, you can tell that A equals F, B equals G, and C equals H. So this is the concept of coefficient equating. This is the concept of coefficient equating. In your early days, we just talked about that. Just consider these two equations. Okay, just look at my screen. Just look at this. I'm highlighting the points that I'm highlighting right now. So what we have done here, that is basically we have just done A equals 1, B equals 8, and C equals 21. And how we have done it? Because we have equated the similar variable. These we have x squared here, and we have x squared here. The similar degree term. Similar degree variable terms. The similar degree variable terms, because x squared and x squared are similar degree variable terms. X and x is also similar degree variable terms. We are equating. Okay, we are equating. So this is the thing that they are doing. They are just equating these things. I'm just gonna write this in nx squared plus 5, nx squared plus m, nx squared plus m is equals to 5x squared plus 4. Just look at this. This n and this 5. They both have the coefficient of x squared, right?
Yeah.
So you can just write n equals 5. And from m equals 4, this problem is solved because they are telling you infinitely many solutions for x. What is the product of the constant? Then we just need to multiply m cross n. We just need to multiply it. Okay, we just need to multiply. And what do we get multiplying it?
20.
20. We get answer D is the answer. So you just need to look at these problems. You just need to think about these problems, and you just need to think as much as possible and use pen and paper. Okay. We are gonna solve some problems, basically some practice real problems that is based on function interpretation and manipulation. Okay. So function interpretation and manipulation, maybe we already know about basic things about function interpretation and manipulation because we have already talked about how to model a situation, how to model a mathematical problem in terms of variables, in terms of function, because our main goal is to understand the situation, then modeling with variables, building an equation, and then solve the equation with values given or assumed. That is our main target. So now we are gonna solve some set problems, the exams that will appear in our SAT test. So look at the problem. You should only take 12 minutes to complete all of these problems. In the equation, E equals mc squared, what is the value of c in terms of other values? Yeah, that's pretty simple. This is just a simple problem based on equation, solving some equation. So uh, in the equation, E equals mc squared, what is the value of c in terms of other values? So what you need to do, that is basically you just need to write the equation in terms of c. You just need to write the equation in terms of c. This is the equation. This is our main equation, E equals mc squared, and you just need to manipulate this equation. This is called algebraic manipulation. You just need to do some algebraic manipulation, and then you just need to write the equation in terms of c. And if you write the equation in terms of c, it will look like c equals root over e by m. That is option C. Option C. Do you understand this problem? Do you have any question?
Yeah.
Okay. So our next problem is the formula to model the height h in meters of an object t seconds after being dropped is h equals something something something, in which h naught is the height from which the object is dropped. If the height of an object 3 seconds after being dropped is 0, what is the initial height of the object? So the formula to model the height h in meters of an object 3 seconds after being dropped is h of t equals negative 4.9 t squared plus h naught, in which h naught is the height from which the object is dropped. H naught is the height from which the object is dropped. If the height of an object 3 seconds after being dropped is 0, what is the initial height of the object? Do you understand the question?
Yeah.
Okay, now tell me, how can you solve this problem? Just give me some idea. Just give me some random ideas. You don't
You
need to
can
give me the
plug
exact
in
solution.
you can plug in 3 to the height and then 0 to the or whatever. Something like that.
Uh, can you at least understand what is basically they're talking about the height h not an h?
Sorry?
Can you please at least tell me what is basically here, H here and H not here?
The H is the height, the T is the time, and H naught is uh like the height from where it dropped.
Yeah, so for an example, if I'm just gonna draw here, so the thing will look like this is considered this is our basically this is the ground, okay? Call this ground. We call this ground or level. Ground or level. Ground or level. So just consider a building. Just consider a building here. So someone here just dropped an object here from this point. Okay. So this is the object. This is the object. The object is falling from here. Okay. So this distance, it is called the H naught. Okay. This is the H naught. And for a random time, just consider for an example, after 2 seconds, the height of the object that is called H, that is H. Okay. That is H. So the H and the H naught, the H and the H naught has difference. It means that H naught is basically the initial height. H naught is the initial height from where the object is dropping from. H naught is the initial height from which point the object is dropping from. Because this object, this black object in the black color, it is being dropped from here, right? So H naught is the initial height, and H is the arbitrary height for any moment later for after 2 seconds. If I'm gonna ask you what is the height of the object after 2 seconds, then the the H that you are looking for, that is this simple H. What is the height of the object after 1.1.98 seconds? Then you just need to calculate the H. But H naught is the constant here. Okay. So the formula to model the height H in meters of an object T seconds after being dropped is H of T equals negative 4.9 T squared plus H naught, in which H naught is the height from the object, which the H naught is the height from which the object is dropped. If the height of an object 3 seconds after being dropped is 0, if the height of an object 3 seconds after being dropped, 3 seconds after being dropped is 0, okay, what is the initial height of the object? So they're just telling you very simple, very simple data they are already given to you. That is, if the height of an object 3 seconds after being dropped is 0, can you just use these values just to model this equation, just to manipulate or just to plug in the uh, values in this equation? Can you do that at least using this data and these data? Can you do that?
Yeah.
Okay, then tell me what is gonna be.
So the H is 3, and then you solve for H naught.
Okay, just think it again and tell me. Think it again and tell me. I have told you the situation here. I've told you the situation. I've tried to make you understand about the whole scenario, okay? The modeling. And now you just need to tell me how to find the answer or how to use this data to manipulate or to find out our desired answer by you plugging in this equation, in this red marked region. Okay, tell me.
Set up the equation and then put 3 in the H, or you could do option
Okay,
S.
what is the for this red mark for this green mark equation, what would be the value of H, T, and H naught? What would be the value of H, What is the value of t and what is the value of h naught?
Oh, okay. So H is 0 and T is 3 and H naught is what you're looking for.
Exactly. Exactly. Thank you. Exactly. Thank you. And that is what we are gonna do. So age, they're telling you if the height of an object 3 seconds after being dropped is 0. So it means that the object takes 3 seconds to fall on the ground, or level. That's not important. That's not important for us. Whether it is falling on the ground or level, whatever it is, we just need to plug the values as they're telling, because they're telling after 3 seconds, t equals 3, after t equals 3, the h is gonna be 0. So we can find the value of h naught equals what? Okay. Can you solve the equation after plugging in the values?
Yeah.
Okay, that's just like h of t equals negative 4 -4.9 t squared plus h naught. So h of t is gonna be 0. Uh, 0 is equals to -4.9 t squared plus h naught, right? So
Yeah.
h naught is equals to 4.9 into 9. This is gonna be your answer. You just need to calculate it, okay?
Okay.
That is going to be h naught. Okay. So body mass index is calculated by taking the mass of a person in pounds and the height of a person in inches and plugging these values into this formula. Okay, what is the mass of a person in terms of our other values? This is quite simple, and you just need to do the same thing like this algebraic manipulation, and you can just solve this problem. Okay. You can just solve this problem just by using the algebraic manipulation. Just writing the equation in terms of other variables. That is basically called the algebraic manipulation. That's simple. Okay. So it was a nice problem. Problem 2 was a nice problem. Okay. It was a nice problem. It was a nice problem, basically. So I think this is also going to be a nice problem. So the height of a rock thrown off a ledge relative to the ground beneath the ledge is graphed below. So the height of a rock thrown off a ledge relative to the ground beneath the ledge is graphed below. At what time did the rock reach its maximum height? The height of a rock, thrown off a ledge relative to the ground beneath the ledge is graphed below. At what time the rock reached its maximum height?
One.
Yeah, I think that is it, the height of the rock, because this is the peak point, right? This is the peak point. This is the peak point, and we're just gonna do some mapping, okay? Just corresponding values. I think 1 second after this row. Thank you.
Mhm.
Okay. So if x minus 5 equals 2x squared plus ax negative 20 divided by 2x plus 4, what is the value of the constant a? If x minus 5 is equals to 2x squared, ax negative 20 divided by 2x plus 4, what is the value of the constant a? What is the value of the constant? It's an amazing problem. At least you can just give me some idea how to solve this problem. X minus 5 equals 2x squared plus x negative 20 divided by 2x plus 4. What is the value of the constant a? I think the topic we covered I think the topic that we covered, this type of problems, that is called identifying constants. Identifying constants. Identifying constants. And in that topic, we covered something like we just need to do something, some algebraic manipulation, so that we can just get some similar looking terms, similar looking terms, okay? Some similar looking terms. We just need to manage some similar looking terms, okay? And how to do that? How to do that? To do that, we just, I'm just gonna see what they're trying to do rather than do it in my way, because in the last time that was kind of a mix. So they're just trying to do the identifying constants in terms of the coefficient equating process. Do you remember this process? Hello.
Hello.
Do you know this process? I told you.
Kind of.
Coefficient equating process.
Kind of. What's this last class? Yeah.
Yeah, yes, the last class,
Yeah.
coefficient equating process. Okay, coefficient equating process is basically, just look at this last line, okay? The coefficient equating process is the last line that they're trying to do. That is this two and this, I'm sorry, these two and these two, this is basically they are corresponding to each other. And this -6 and this A is corresponding to each other, and this -20 and this -20 is corresponding to each other. And this is called the coefficient equating process. This is called the coefficient equating process. And for any polynomial, this is one of the most fundamental, concepts of polynomial for two different polynomials. You can say like this, and and they are doing a very simple thing, that is they are just multiplying this term with this term, because this is the numerator here and this is the denominator, right? And you can do some cross multiplication, right? Some cross multiplication, and they're just doing cross multiplication. And after multiplying this with this, you get something like this: x -5 multiplied by 2x plus 4. If you multiply this, then you get this. And if you simplify it, you get this. And after doing the coefficient equating process, you can say that a equals -6. Do you have any question?
No.
It's a simple problem, I think so. So I think the rest of the problem is basically kind of same, but the last problem we're gonna do, that is the last problem, that if you just look at this problem 9, something equals something, what is the value of c? Same way, same procedure. This is called coefficient equating process. 6x squared negative 8x plus 8. 6x squared negative 8x plus plus 4. I'm sorry, plus 4 plus 4 plus 4 plus 4 is equals to ax squared plus bx plus c. So what is the value of c? Coefficient equating process. So c is going to be 4, right? I'm solving this question. This is going to be the c equals 4. Okay. So
Yeah.
this problem 10, what is the slope of the line formed by the equation above? What is the slope of the line formed by equation above? So to find the slope of the equation above, you can do it in some different ways, but this is basically maybe they're just maybe they're just asking you to find the slope of the line find the slope of the line of. I just want to look at how they're solving this problem, because this problem can be solved in many different ways rather than trying to do in my way. Okay. We are asked that how can we get the slope of this equation? And to
Okay, I
do
have a
that,
question.
yeah, sure.
Because I was looking at the equation before the answer was shown, and I looked at the bottom is because x, like, to find the slope is y equals mx plus b, and I saw that 2, so I just thought it was 2, and this is 2, so I don't know if that's okay too.
So you are just trying to tell a shortcut from, right?
Yeah, but I don't know if that's always right.
Mm,
Because look at the bottom is y equals 2x plus 6, which is the same formula equals y equals mx plus b, so I just thought 2 was the answer.
okay, but slope, you're just trying to tell that y equals, you're just trying to tell the term in the denominator, right?
Yeah.
You're just telling the term in the denominator, that is the slope is 2 here, because uh, that is 2x plus 6. Am I correct?
Yeah.
You are just trying to tell the denominator, we have 2x plus 6, we have 2x plus 6, and from that we can tell the um, slope of the line is 2. Is that?
Well, yeah, but I'm just asking if it's okay. Like,
And no,
is that
uh,
okay? Is that a way?
uh, let's look. I don't think that's the way, because I don't think, maybe I don't think that's the
But
way,
the
because
answer is still the same, so.
the answer the answer maybe becomes same, but the thing is, they're not asking you for, maybe they're not asking you for this very particular line, not for
No,
this
I
very
know, but
particular
it
line.
just has to find the slope, so it doesn't matter how you find it.
Okay, all right. But I don't think that's. I just want to look at the problem
Yeah,
solution,
okay.
how they're trying to do it, rather than telling something from my end is not going to be correct. Okay. So manipulate this equation to get it in slope intercept form. So they're just doing some simplification. And after the simplification, they're just telling you that it is basically y equals 2x minus 6. So 2x minus 6. And the very first thing that anyone can make mistake, that anyone can make mistake, that just look at this equation. This is 4x squared negative 36 by 2x plus 6. Okay, 2x plus 6. So look at this equation. This is a second degree order polynomial, right? Second degree order polynomial. Second degree order polynomial. Because we have x squared. We have x squared. Okay? X
Hmm.
squared. So the exponent is 2. The exponent is 2. So maybe the maybe you can just look at this equation, and maybe you would think that maybe it is gonna look like a parabola divided by a intercept, maybe something like this. No, but that's not the way. Okay? That's not the way. That's not the way. It's correct. It's incorrect. It's incorrect. So what you need to do that is, you just need to make this equation look a very in easy terms. Do some algebraic manipulation. You're just gonna do some algebraic manipulation, and after doing this algebraic manipulation, you are getting this simple line. And from this line, you can just say that this line has this straight line has this slope S O P equals 2, which is basically my equals x plus c. Okay, so your answer is correct. You gave me the correct answer, but they're just trying to do some taking some common, and then just they are just trying to simplify it. They're just trying to simplifying and manipulation. Okay, they're just trying to do some simplifying and manipulation, and after that, they're just getting you this answer. Your answer is correct, but that's not the right process. I'm just telling that, okay?
Mm.
Grazing can be sometimes good, but as there is no negative marking, so that is it. Whatever. We have some other problems and just a little bit of problems. So now let's look at a new problem. Now let's look at a new problem, which is um, problem number 6. The moon orbits Earth once approximately every 27 days. Titan, a moon of the planet Saturn, orbits Saturn once approximately every 16 days. For every full planetary orbit the moon of Earth makes M, how many orbits of Saturn or fractions thereof will Titan make of Saturn T? It's a nice problem. Okay, so the moon orbits Earth once approximately every 27 days. The moon orbits Earth once approximately every 27 days. Titan, a moon of the planet Saturn, orbits Saturn once approximately every 16 days. So for moon, which takes 27 days, 27 days, but on the other hand, for the Titan, it takes only 16 days, only 16 days. So for every full planetary orbit, the moon of Earth makes, for every full planetary orbit, the moon of Earth makes M. How many orbits of Saturn or fractions thereof will Titan make of Saturn? So, do you understand what they're asking? Basically, they're just trying to ask you. They're just trying to ask you. They're just trying to ask you for every full planetary orbit of the moon of Earth makes. It means that for complete, for one complete planetary orbit, for one complete planetary orbit that our moon is gonna do, we comparing, we need to compare that with Saturn, that with Titan, basically. Okay, so how do you solve this problem? It's a very simple problem.
Um, 27 over 16, or the other way.
Let's look 27 or 26. You're just trying to tell the option C, right?
No, you can simplify it. I'm
Okay,
just saying.
you're just saying, okay, but just give me a choice of yours. Just tell me which one do you think?
I think it's either B or D.
Either B or D.
Yeah.
Okay, let's look what they're telling. Problem number 6. Okay, problem number 6. Okay, problem number 6. Either B or D. Okay. Um, so basically they're just telling you, they're just asking you for one complete planetary orbit then moon is doing. For one complete planetary orbit that our moon can do, what is the required time for Titan? What
16.
is the required time? So you just, that's a very, very, very simple problem. You just need to make some divisions because they're just telling you, just I've just given you the solution here by writing these type of sentences. For moon, which it takes 27 days, for Titan, it takes 16 days. So
Yeah,
they're
but why
asking,
wouldn't you wouldn't
sorry,
simplify it?
please ask the question
You wouldn't
again.
simplify it?
Uh, I would simplify it, but I don't need any kind of simplification, and I
Okay.
don't I don't really I don't think we just need to do any kind of simplification or algebraic manipulation or whatever you say, because this is just a simple problem of This is a word problem. Just treat it like a word problem, okay? Treat it just like a word problem. Basically, for moon which which is taking 27 days, but for Titan it is only taking 16 days, okay? Only taking 16 days. So they're just asking the portion of Saturn that Titan is making the orbit. The orbit that Titan is making, the orbit that Titan is making, the orbit that Titan is making for Saturn. So to solve this problem, we just need to understand, just read it. So it takes the moon 27 days to make a complete orbit of Earth, and it takes 16 days to make a complete orbit of Saturn. So if the moon has made a full one orbit, 27 days have gone by. In that time, Titan would make nearly two orbits since the orbit moved quickly. To be precise, it would make 27 by 16 orbits. Therefore, the answer of choice is C, 27 by 16. Yeah. Another way to think about this, Titan makes 1 by 16 of an orbit in one day. Since it takes the moon 27 days to make a complete orbit, Titan would make of an orbit in the time it takes the moon to make a single orbit. Just a word problem. Just a word problem, okay?
Okay.
So just like for moon which it is taking 27 days, for Titan which it is taking 16 days. 16 days. So Titan would definitely make the orbit, make the orbit, make the orbit uh, faster or more than moon can do. So 27 by 16 is our desired answer because it is gonna cover approximately two orbits. Approximately two orbits. So you can just guess the answer from just by looking the options 27 by 16. And I don't know if it is can simplified because 20, I don't know if whether 27 and 16 has a common product or multiples inside them, but you just cannot make it you just cannot make it any shorter, any fundamental form than this. 27 by 16 is maybe the most fundamental form of its own. So that's why I don't think there is no question of simplification. Do you understand what I'm talking about?
Yeah.
Do you have any question?
No. But
Okay.
I like
Yeah.
because if you, I'm just saying, that's how I thought. Because 27 can go down to 9 and then 16 is 4 because 4 times 4 is 16 and 9 times 3 is.
Can you
I'm just,
divide this? Okay. Can you divide this numerator and denominator with the same number?
oh, okay. No.
No, you cannot do that. So
Yeah.
you cannot do that. So definitely you cannot make it shorter or you cannot
Okay.
make it more fundamental. Okay.
Okay.
For an example, if you just can divide this 27 with 3, if you want to divide this 27 with 3, and then you also need to divide this 16 with 3, but that's not possible.
Yeah.
Or any number, you just need to divide the numerator and the denominator with the same number. And after doing that, you can just simplify it or you can just make it in more fundamental. But that's not possible here, and that's why we cannot write 4 by 9 or 9 by 4, whatever it is. And that is it. Okay. So problem number 7. This is the last problem of our chapter, and it was an amazing chapter. And this is our last problem of this chapter. The number of geese at a lake tripled each year, which, when compared to the number of geese on January 1 to each year between January 1, 2017 and January 1, 2020, if there were 810 geese on January 1, 2020, how many geese would be there have been on January 1, 2017? The number of geese at a lake tripled each year. The number of geese tripled each year. When compared to the number of geese on January 1, of each year between January 1, 2017 and January 1, 2020, if there were 810 geese on January 1, 2020, how many geese would have been on January 1 to 2017?
Can I guess the answer?
Yeah, you definitely can guess the answer.
Is it 270?
270. Let's look whether it is 270 or something. So, but the thing is, they're just asking you the number of gays at a lake
Yeah, I
triple
know.
each year. So it is
Yeah.
just becoming triple in every single year. So
So
when
you would
compared
just
to
divide it by 3.
uh maybe 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 divided by threes, or um for an example, if first x is the first number in January 1 to 2017, then 3x is gonna be for 2018. This is 2017, just write it here. I'm just guessing, I'm just telling you. X is 2017, and then 3x is 2018, and 3x. So this is gonna be 9x squared for 2019, and then 9x squared 3, which is gonna be 27x. No, there is no x squared term. I'm sorry. So I'm just guessing 9x and then 27x in 2020. So 2020, in 2020 we have 810. I'm just guessing just like this. Now just look problem number 7. Okay. Uh, this is problem number 7, right? Problem number 7. Problem number 7, yes. What is the answer? Problem number 7. Hmm. They're just telling the answer is 30. Okay. Okay. Um, 27x. 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 27x is equals to 810. So what is the value of x?
Oh, wait, I missed a year. Because 270 is 2018.
What is the answer?
Yeah, 30.
Is it 30?
Yeah, that's what it says.
I don't know, but let me calculate because I'm very bad at
Oh,
calculation.
I don't
Sorry.
know about you. I'll just say.
810 divided by 27. Oh, that's 30. I'm just guessing. Okay, now let's look how I thought this problem should be. Uh, I've just modeled, and the way that I modeled, that is basically, I just thought, I just assumed, the, I have already told you the process of how to solve function problems, that I assumed the very first number or the very first amount of the geese that was 2017. And I'm just assuming the number of geese were x, right? I'm just assuming the number of geese were x. And it is tripling each year, and it is tripling each year. So it means that in 2018, it is going to be 3x. Because in
Oh,
2017, the very first year, it was x. I'm assuming it is x. And the next year, it is going to be 3x because it is tripling. And the next year, it is going to be 9x. And the next year, it is going to be 27x. I'm tripling. I'm just tripling because I'm just multiplying this x into 3, which is becoming 3x, and then I'm just multiplying it by 3, and then I'm getting to 9x, and after that I'm also multiplying it with 3, and I'm getting 27x. Do you get my point?
yeah, yeah.
And finally, they have given you the number 2020 January 1, 2020 January 1. The number of geese is 810. 810. So you can just equate the 27x is equals to 810 because 27x is nothing but the number of geese. Now we started our calculation from 2017 and we have finally made it through. We have finally made it through to 2020, and The number of geese in 2020, that is basically 810. So you just need to equate it. I don't know how they solve this problem. Okay, they're just doing some other way, but I'm comfortable with algebra, and that's why I'm just doing in this way. But this is not algebra. This is basically simple arithmetics. They're just doing in the arithmetics, but I'm comfortable with algebra, and that's why I'm doing it in this way. Okay. My problem procedure, I think that is more comfortable for you. I think so. Do you have any question? Do you have any question?
No. Are you gonna
Do
do
you?
number 8?
Sorry.
Are you gonna do number 8?
We have already completed number 8. We have already completed number 8. Oh, okay. Sorry. Oh no, we haven't completed. We haven't completed number 8. What is the y-intercept of the graph of the following equation? The same thing, right? Kind of same thing, just like we have done here, but not the exact one. But what is the y-intercept of the graph of the following equation? We have done a simple. We have done a problem like that. We have done a problem like that. That is basically um, y-intercept, finding the y-intercept of the graph. Let me give you the example that we covered. Let me give you the example that we covered because it's really necessary. Identifying constants. We have solved a problem. We have solved a problem like this. We have solved a problem like this. I still remember in one of our example, we have solved a problem like this. The exact same problem. Yeah, yes, exactly. Uh, but not like this. Example number 2. Maybe example number 2, but not like that. Okay, now try to understand what they are asking basically. Problem number 8. Problem number 8. What is the y-intercept of the graph of the following equation? So the y-intercept of the graph of the following equation, the y-intercept would be basically those points where x is equals to 0, right?
Yeah.
Because y-intercept means that the for an example, just consider this two-dimensional plane, two-dimensional coordinate system. Just consider this simple graph, and the points and the points, excuse me, and the points in which this green shaped curve is crossing or intercepting the y-axis, because they're asking you the y-intercept. So we just need to consider about the y-axis. That is basically this point. This is basically this point, right? The only point, this point. So if you are really, if we are interested to think about this point, so at this point, the coordinate x is equals to 0. X is equals to 0. So maybe we just need to think about in these terms, what is the y-intercept of the graph of the following equation? So we just need to find the values where x is equals to 0, where x is equals to 0. Okay, because because we already know that x is equals to 0, then we can find the y. We can find the y. Let's look how they are solved that problem. Problem number 8. Problem number 8. So they have just taken the equation and then they have vectored it and cancel the x -3 and y-intercept. Technically, they have done the same kind of just plug x is equals to 0. So, and they're finding the y value. That is it, what I've just told you, because I am just telling you that you just need to find out the x is equals to 0 and you just need to find the y. Okay. Do you understand?
Yeah.
Because I am telling you that the y-intercept means the x equals to 0. X is equals to 0 and what is y equals to? What is y? X is equals to 0 and what is y? X is equals to 0 and what is y? X is equals to 0. X is equals to 0 and what is y? What is y? They have just put the x equals to 0 and they have just find out what is y. And this is just nothing but some algebraic manipulation. Y equals 2x squared negative 18 divided by x minus 3. Factor it, the numerator. You just need to do some common things, or yeah, you can do some common. You can take, yeah, common 2, and then x squared minus 9, x minus 3. And after that, you can just write 2, a squared minus b squared, a plus b, a minus b, and then x, and this thing cancelled, and we only have 2x plus 6, which is 2x plus 6. And after that, we can write y equals 2x plus 6. As x becomes 0, y becomes 6. Do you understand?
Yeah.
So the answer would be 6. So the answer would be 6. Problem number 8. The answer would be 6. That is it. This is our chapter looks like, and this is how it's gonna end here. So 2.5, and I just want to do a simple brief. I just want to do a simple, because I think it's one of the most important chapter in the whole SAT. One of the most important chapters in the whole SAT. Interpretation and manipulation functions. Function interpretation and manipulation. Putting the variables in terms of other variables, we have done that, because we have this is nothing but some just doing some simplification and algebraic manipulation, and then we have covered how to model any situation in terms of mathematics, and how to find the answer, because modeling and doing etc. And then this was a nice problem. How you just cannot cancel. I'm just talking about this twice and minus one problem here. The twice and minus one problem. It was a nice problem because I did it in the wrong way. Technically in a wrong way, but not the exact wrong way. I was mistaken here. So identifying constants, and then you just need to do the coefficient equating process. We have done the coefficient equating process. We have done the identifying constants, and then sorry. So and then we have done some. We have done some amazing problem here in example number two. Because it was an amazing problem. Because we cannot solve this equation, because that will take a lot of time. Solving the equation is not a good idea. And zeros of the equation is a good idea, but not that, because that is too much time taking. So rather than we just need to consider in terms of coordinate geometry, because uh, where the points will intercept the x-axis, the value would be just like x negative 4 is equals to 0. So technically, you are just finding the zeros of the equation, but you are not doing the whole manipulation, the exact line by line procedure, because that will take a lot of time. Rather than they have already simplified it for you, and then just equate it with 0, and then solve it. Okay. So interpreting functions, this is our main problem. We have understood the model, and we have talked about maximum and minima. That was basically related with our calculus problem. And we have done so many problems which were necessary for our SAT problem look like solution. Okay, SAT problem and look like solution. Okay, we have some other problems here too. And I think these problems are quite similar, uh, like the D4 problems we have done. Okay? So this problem I'm suggesting you to do the practice here, because this is one of the most important chapter in the whole SAT, and I think it is the most critical chapter. I think the most critical chapter is this. Okay, the function for anyone, for anybody. Unit 4 and unit 2, the 2.5. That is, I think it is the most complex. So uh, we have some extra problems here too, and I'm suggesting you to go through these problems, and all the solutions are given here. So you can just try try to solve this problem, and I think I'm just gonna do at least one of them here, because I had no plan to touch it, but I'm also doing it. I'm just reading the problems. Can you hear me? Hello.
Hello, can you not hear me?
Yeah, can you hear me?
Yeah, I can hear you.
Is it boring?
No, I can hear you.
Okay. So we have some extra problems here. So I'm just trying to read the problems. In physics, force F is equals to the mass M multiplied by the acceleration F equals m. What is the acceleration in terms of force equals m? Algebraic manipulation, as simple as that. In a sphere, the surface area S is calculated using the formula S equals 4 pi r square, where r is the radius of the square, what sphere, what is the value of the radius in terms of surface area? Algebraic manipulation and simplification, as simple as that. If A is a positive constant, what is the value of A in the equation? Coefficient equating process. Coefficient equating process. Coefficient equating process. Multiply them, these two numbers, multiply so these two terms. You just need to multiply it, make a polynomial from these two, make a polynomial from these two, and then equate it with that polynomial on the right side. And you would find the answer. As simple as that. The solute potential of a solution, the solute potential of a solution, the solute potential of a solution, psi s is calculated as follows. This is called the psi. Okay? This is called this Greek letter. This Greek letter looks like this. It is called psi. It's called psi. Okay, it's a Greek letter. Psi. So the in this equation, I is the ionization constant, C is the molar concentration, R is the pressure constant, and T is the temperature in degrees. What is the molar concentration in terms of other values? The solute potential of a solution, the solute potential of a solution psi S is calculated as follows. In this equation, I is the ionization constant, C is the molar concentration, R is the pressure constant, and T is the temperature in degrees Kelvin. What is the molar concentration in terms of other values? In terms of other values. So this is nothing but just giving you some tough words, okay? They're just telling you some, giving you some tough, tough words, tough words. Excuse me, I'm sorry. They're just telling you some tough words, but the problem is algebraic but the solution is algebraic manipulation because you just gonna rearrange them. And algebraic manipulation is nothing but rearranging, rearranging the equation, rearranging the equation, rearranging the equation. As simple as that. As simple as that. Rearranging the equation. Just rearrange them because you just need to understand what is the meaning of each variable. What is C? What is T? What is R? And what is psi S? And then what they're asking, what is I? What is I? What is R? What is C? What is T? And they're just then asking, what is molar concentration? What is M? I'm sorry, what is C? So write the manipulation. This is the equation. This is the equation I negative I C R T. They're just asking you, what is C? What is C? C is nothing but C is equals to negative psi S divided by negative psi S divided by I R T. As simple as that. Child game. This is just a child game. Do you have any question?
No, not yet.
Okay. So the height of H ball thrown, as simple. Okay. We have done similar problem like this just a couple of minutes ago. Just a couple of minutes ago. After how many seconds would be the ball's maximum height? The height h of a ball thrown from the top of a ladder that is 10 feet above the ground and t seconds after being thrown. And t seconds after being thrown is calculated using this function. So after how many seconds will the ball reach its maximum height? The height of a ball, the height h of a ball thrown from the top of a ladder. For an example, if this is the ladder, just consider it just like this. This is the ladder. This is the ladder. And someone here is shown is throwing a ball from here, a ball from here. So this is gonna be like this. Okay. Okay.
Mm.
So this is it, and this is the ball. This is the ball, the violet color. So after how many seconds would the ball reach its maximum height? It's an amazing problem. It's an amazing problem. How to solve it? Can you solve it with the concept of maxima and minima? Maxima and minima. Can you solve it using the
Yeah,
concept of maxima and minima?
yeah.
I don't know, but I can try at least. I can try. So if you are using the concept of maxima and minima, if you are using the concept of maxima and minima, then the thing that you need to do, that is basically you just need to do that. Why? For what is the maximum height, right? They're just asking you after how many seconds would the ball reach its maximum height. So h is basically the um the height of the ball from the ground. The height of the ball from the ground. Maybe this is the height. Maybe the situation can look like this. Maybe the situation can also look like this. Because we have this is a projectile motion. And we call this in physics projectile motion. So for an example, if this is the situation, then if this is the situation, then the projectile motion can be like this, like this. It can also be, it can also be, it can also be like like this, and it can also be like this. Because in this case, the initial velocity is like in this direction, okay? Initial velocity, and in this case, the initial velocity direction, the direction of this initial velocity is parallel to the ground. And in this case, the initial velocity direction is in this way. So I'm not gonna think about this all of this situation because I'm not gonna solve this in this way because I'm just telling you some basic physics. But you don't need to understand this type of physics to solve this problem. You don't need to understand this physics, but there are four types of projectile motions. Okay, there are four types of projectile motions. There are four types of projectile motions. I'm just letting you show the basic three types because this is completely a physics. So what we need basically, that is, we just need to find the maximum height. We just need to find the maximum height. We just need to find the maximum height. So the way then we can find the maximum height after how many seconds would the ball reach its maximum height? That is, we just need to find the maximum height. And can we solve using the maximum minimum? Because if we use the maximum minimum concept, would that be simple enough for us? Now let's look at this concept. I'm just telling you whether using this problem, whether using the maximum minimum concept to solve this problem is a good idea. Just trying to let you know. I told you this is the most important chapter, the most important chapter in SAP Math, and the most time-taking chapter to understand. Okay, because it's a tremendous chapter. Anyway, so the maximum minima I completed here, maybe yes. For y equals, if you remember, that is y equals x squared plus bx plus c. The maximum x equals negative b by 2a, negative b by 2, and the n value, the value of n that is giving you the greatest corresponding n value of p. So we were interested, to know about the greatest p value, the greatest p value, the biggest p value, the biggest p value, the biggest p value. What is causing the biggest p value? What is uh, happening? What is happening just because of n? The biggest p value, if you remember, a company's profit p for selling n product is modeled by the following function, y p equals dot 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 dot. For how many products should the company sell to achieve its maximum profit? Because they're interested to know about the maximum p, but and what the maximum p is caused by the n. So just like here in this problem too, just like here in this problem too, just like here. in this problem too. We are interested to know about this maximum h. The h would be the maximum. The h would be the maximum. H would be the maximum. H would be the maximum. And our point of interest is what is what is causing what is causing to be maximum of h. What is causing? So this is the maximum and minimum problem. Just just think this equation is just like y equals ax squared plus bx plus c. And to be y maximum, the value of x is negative b by 2a, negative b by 2a, negative b by 2a. And for this equation, to do this equation, we can analogously compare, and then we can tell, that this b for this equation, the b would be let me tell you from let me write from a equals negative 16, b equals 20, and c equals 10. So after how many seconds the ball reaches its maximum height, that is x is equals to, or t is equals to negative b by 2a, negative b by 2a, that is 20 divided by 32. Can you simplify it? Yes, we can simplify. Okay, 10 by 16, we can also simplify it by 5 by 8, right? Um, okay. Uh, yeah, 5 by
And then
8.
do you
5
change
by
that
8.
to decimal?
Sorry?
Do you change that to a decimal form?
No, I don't think we just need to change it from decimal point. Let's look at the answer first. Am I doing it correct or am I doing it wrong? 5 by 8 is that 20 divided by 32. 20 divided by 32, right? There is, have I done 20 divided by 32? Yes, I have done 20 divided by 32. 20 divided by 32 is that? Yeah, 20 divided by 32. You just need to change it in decimal points. Maybe whether it is, you just need to just look at this problem. Okay, all right. They're just giving you the answer in decimal points. So you definitely need to convert it. So definitely you need to convert it. But have you grasped the idea? Have you grasped
Yeah.
the concept how to solve this problem? Because we are using the concept of maximum and minimum. Okay,
Yeah.
just be honest with yourself. Have you
Yeah.
grasped this concept? Because I'm putting this time just because of to make you understand, because these concepts are really too much important.
Yeah.
Are you sure?
Yes.
Okay, all right. So we have some similar problems like this way. So I think this is quite easy for you. It's possible. And then this is a coefficient equating process. And then these are quite simple. And I think the only problem that you can just solve at your home, that is basically this problem number 6. Problem number 6. And this is how our chapter 2.5, our function manipulation and integration, ends here. This is how our chapter function manipulation and integration is ending here. Look at the problem number 7. Problem number 7 is telling the graph above represents all the values for functions g of x, and as graphed in the xy coordinate plane. What is the difference between the minimum and maximum value of the function? The maximum value is basically this, right? And the minimum
Yeah.
value is this. And you just need to subtract what is the difference between the minimum and maximum value. The minimum value, uh, g of x, the graph above represents all the values for the function g of
Oh,
x as graphed in the xy coordinate plane.
there would be 8, or is it asking to subtract the y value or the y line or the x line?
Uh, I'm asking this question. What should you do?
Well, obviously you would subtract, but I'm asking, is it
Okay,
asking to
but just guess
subtract
your
the x?
idea. You can just guess. What should you do? What should you do from our previously discussed concepts? Which one should you subtract? Which one should you subtract?
I think
The function is
the,
g of x, okay? G of x.
okay, I think you would subtract the y.
Okay, then
So
why? Okay, then why?
10,
Why should you subtract?
because g of x is also known as y value.
Exactly, exactly. So g of x is nothing but the y value. G of x is nothing but the y value. And the most important thing that is in this g of x, x is the input. And we know the convention of writing any function, declaring any function. We know the convention. I told you, okay? I told you the convention of declaring any kind of function. Declaring any kind of function. For an example, if shy is a function, then if we write shy of t, it means that the name of the function is shy, the name of the function is shy, and t is the independent variable. T is the independent variable, it is the function, it is the input. It is the independent variable, and it is also the input. It is also the input. So here in this case, g of x for this problem, so for this particular problem, x is the input, and x is also the independent variable. Independent variable. So our dependent variable would be y. Our dependent variable would be y. Our dependent variable or output would be y, which is nothing but the output, So you need to subtract the y value. You need to subtract the y values. What is the difference between the minimum and the maximum value of the function? So the y value is the function value. The y value is the g of x value and the function value. So the maximum would be minimum and maximum. Let's find out the maximum. The maximum would be uh the maximum would be 10, right?
Yeah,
The y value, which is the y value. This is the maximum value for this point, corresponding this point. This is 10, and this is maybe 1, 2. This is 2. This is x equals 2, and this is y equals 10. This is y equals 10, and this is x equals 2. And for this point, this is x equals 5, and this is y equals 2. But we are only considering about the y values because we're interested about the dependent variable or the output variable or the out. So the maximum is 10, and the minimum and the minimum and the minimum is equals to 2. The difference is 8, right?
yeah,
Yeah, that's it. So but the concepts are quite important because g of x is the function. Here, maybe if it was written in like this g of y, if it is written in just like this, then y was the input here. Then y was the input here. Y was the input here. And why is the independent variable in that case? Why is the independent variable in that case? And the dependent variable is x. And the dependent variable is x, but that's not technically possible because as I have already told you, and as I have already mentioned you, that mathematicians really don't go outside of the conventions because they really prefer conventions because they really try to make it understand easier for you. So that's why x is x is an universal variable, and if you want to replace it with some other letters, you can do it. But the letter x always represent a variable, an independent variable. So maybe you don't find any kind of problem where g of y here, y is the input variable or the independent variable, and x is the dependent variable. You won't find some problem like this, but maybe they're just gonna change this variable in some other variable, in some other letters. Maybe this is gonna be W, and this is gonna be, for an example, H. Just think about this problem. This is going to be W and this is going to be H. Maybe the function can look like G of W is equals to something. And what is the minimum and maximum value of H? Okay.
Mhm.
Just try to make your mind a little bit working inside about the mathematics, and you can automatically relate because you already know a lot of things anyway. So problem number 8, in the expression above, in which k, a and b are constant, what is the value of k? So this is nothing but the equation, this is nothing but the coefficient equating process. You just need to do the coefficient equating process, okay? So if you're gonna do that, then the solution will look like just like k a x squared, I'm sorry, k a x squared plus kb x plus 5k. Do you understand how I am taking these things? How I'm doing
Yeah,
this?
yeah.
Because I have just multiplied this k with, okay? I've just multiplied this k with every single term, okay? Every single term. Just give me a moment. Okay. So, and now you just need to find a, and b, which is the value of k. Which is the value of k? Just think about this simple thing.
I can't hear you well.
You can hear?
I can't hear you well.
Okay, all right. Give me a moment. That is what I'm working on basically. Can you hear me now?
Yeah.
Okay, thank you. Thank you.
Yeah.
Thank you. So this is coefficient equating process, and you just need to equate them and you can find the value of k. Is that simple? 5k equals 15. 5k equals 15, so k equals 15 divided by 5, which is 3.
Yeah.
Okay. So problem number 9. If f of x equals x squared minus 4 and f of x plus n equals x squared plus 6x plus 5, what is the value of constant n? It's an amazing problem. And to solve this problem, we need to know what is, when you just giving some input, when you are just giving some input. So input inside a function. Now I'm interested to look at the solution that how they have done, because that will be more preferable for us. So plug x plus n into f of x equals x minus 4, x squared minus 4. Then make this expression equivalent to x squared plus 6x plus 5 to solve for n. Because we are already given, just look at this problem. We are already given that. We are already given that f of x is equals to x squared minus 4, right? We're already given this function.
Yeah.
We're already given this function. So if you're just gonna plug this x plus n into this x, then what are you going to get? Then what are you are going to get? You are just gonna get f of x plus n, which is you're just gonna replace every single x with x plus n, x plus
Mm.
n whole squared, negative 4. X squared minus 2nx plus n squared negative 4. So this is going to be x squared minus 2nx plus n squared minus 4. Okay. So, excuse me. So now you just need to equate the two equations. You just need to equate these two equations. Equate these two equations, and after the coefficient equating process, coefficient equating, do you remember what is coefficient equating? Do you understand what is coefficient equating?
Um, I know what you're talking about, but I forgot what it looks like.
Coefficient equating means that you just need to equate the coefficients for same looking like terms, coefficient equating means you just need to equate the same variable, same degree terms. which means that you're just gonna need to solve just like in this way, that we have x squared here, we have also x squared here, the same variable, the exact same variable with the exact same exponent. So you can just relate them. You can just relate them
Oh
because we
yeah,
have
yeah.
two different
Okay. Yeah.
equations. For an
Yeah.
example, equation one in the left hand side, and then equation two in the right hand side.
Yeah, I know what you're talking.
And then you can just, for example, equation one has some coefficient like a, b, and c, and equation two have some coefficients like e, f, g. Then you can just tell them a equals e, b equals f, and c equals g. This is it, as simple as that. So you just need to do some, first of all, you just need to do some algebraic manipulation, and then you can just equate it. We are already given this function f of x equals x squared minus 4. And here in this x, in the function, you just need to put the x plus n. And putting the x plus n in this function, in this very function, you are just gonna get something like this. You are just gonna get something like this. You're just gonna get something like this. And after getting this, you are just gonna equate this. You are just gonna equate this violet mark equation, violet mark expression with this expression, because this expression is already given. And after writing them equal or a coefficient equating process, you can just easily write that 2x and equals 6x, because we are gonna find the value for n, right? You can also solve just like, for an example, n squared minus 4 equals 5. I'm just gonna take this single yellow highlighted term, these two yellow highlighted term, because these are also coefficient. So n squared minus 4 equals 5, or n squared is equals to 9. So n equals plus minus 3. In the option, we're just gonna look at what are the options that given. Are they preferring negative values too? No, they're not just giving you plus minus 3. They're only giving you plus 3. So this is
Wait,
the
so
answer.
I'm not understanding this. How are you getting three again? Like you put the coefficient, the equation, but how are you getting three?
Okay. This is an expression, and this is also an
Yeah,
expression, right?
yeah, yeah,
And you are just equating these two equation like this. Equation one equals equation two.
yeah. I know that.
And after doing that, you can just do some coefficient equating, like a equals e, a equals e, b equals f, and c equals g. Can you say that?
Yeah.
So what we have done, we have just equated with the yellow highlighted terms. We have just written n squared minus 4 equals 5.
Okay.
Can you do that?
Yeah.
And if you're gonna solve n squared minus 5, you're just gonna get plus minus 3. N equals plus minus 3. And if you're not interested to think about the last term, you can also think about just like this way. The green highlighted
Oh,
term.
mhm.
Just
I
an
understand.
example. Just an example.
Okay.
2xn equals 6x. X and x are cancelled. So now n becomes 6 divided by 2, which is 3. This is
Okay, I
also
get
a
it.
process.
Okay.
Okay.
Yeah.
I've just tested that if you are just gonna take these, I have just taken this n squared minus 4 equals 5 just to be sure, just to be assured of that I'm not, I'm gonna get every single same answer, whether I have taken the coefficient of A, B, or C, whatever it. I'm just gonna be sure that if I'm gonna work with this green region, I'm gonna get the same exact answer if I'm gonna work with the yellow region too. This is it. That's it. We are done. This chapter is gonna end here. So I think we don't have any problem. We have solved all of every single problem, every single problem that is possible for us to solve. And this is how our chapter ends. This is the end of chapter function, interpretation, and manipulation. Thank you. Thank you so much.